Hello everyone. I will be starting with the session now. Dear authors and invited guests, welcome to Technical Session 9B. I am Deemahi Patel and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Information and Communication Technology for Intelligent Systems, Bangkok, Thailand. The 9th edition of the conference is being organized in a hybrid mode. The physical event was held on 4th April in Bangkok, and the virtual event is being held through Zoom for 5th to 6th April 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Now, before we start with the presentations, I would like to introduce you all to the chair for the session. We have with us Dr. Kilol Vishnuprasad Pandya as our session chair. He is currently working as an associate professor at Electronics Communication Engineering Department at Charotar University of Science Technology, Gujarat, India. His areas of interest are MIMO antennas, DRAs, active patch antennas, and metamaterial-based antennas for wireless communications. He has published over 30 journal papers and 15 plus conference papers. I welcome you, sir, and I request you to share any few words you may have for the presenters here.
A very good morning, Dimahi and all team ICTIS. It is always been a pleasure to work with you guys as I personally observe whatever you have done in the past regarding all the conferences is all everything is up to the mark. And for today also, I wish my best wishes. I give my best wishes to all the presenters, and I hope all the presenter would present novel research which would be applicable to all real-time applications, and that will also help the society and to the nature. So, without wasting any time, I request Dimai to start with the session with the first presentation. Thank you.
Yes, sir. Thank you, sir. I will request Sayyida Muntaha Ferodos. Sayyida, ma'am, are you here with us?
Yeah, I'm here.
Yes, ma'am. Please present your paper on Blossom AC PRED computational identification of anti-cancer peptides using BLO-SUM62 based screening.
Sure. Let me share my screen with you. Can you see my screen?
Yes, ma'am.
Good morning, everyone. I'm Saida Muntaha Firdaus, and I'm honored to be here today at this prestigious international gathering to present our research titled Blossom AC PRED Computational Identification of Anti-Cancer Peptides using Blossom 62 based screening. This work is a collaboration with my esteemed co-authors Shafayat bin Sabbir Mugdha and Mahtabuddin from the Department of Computer Science and Engineering at United International University in Bangladesh. Let's move on to the big picture and the introduction. As we all know, cancer remains one of the leading causes of death globally. The World Health Organization reports that nearly 10 million people die from cancer each year. While we have made remarkable advances in treatments from chemotherapy to immunotherapy, many of these methods are either non-selective, highly toxic, or cost prohibitive for long-term use. This is where our anti-cancer peptides or ACPs offer real hope. These small proteins have the ability to selectively target and destroy cancer cells without harming healthy ones and making them a promising next generation therapeutic option. But here's the challenge. Experimentally identifying ACPs is a slow, expensive, and labor-intensive process. That's why there's a growing push for computational methods, tools that can predict potential ACPs quickly and accurately, narrowing down candidates for lab testing. And that's where our foundation that's the foundation of our work, Blossom AC PRED, a machine learning based model designed to accurately identify anti-cancer peptides using biologically meaningful features. Research objective and key motivation. Our goal was to build a tool that was accurate, biologically interpretable, and practical enough to be integrated into large-scale peptide discovery pipelines. Here's what sets Blossom ACPET apart. First, we used Blossom 62 substitution matrix as our core feature representation. The matrix is based on observed evolutionary mutations and captures meaningful patterns between amino acids. Second, we address dataset imbalance, a common problem in peptide classification by using SMOT, SMOT, and a synthetic oversampling technique, which helped our model generate better. Third, we tested 7 different machine learning classifiers. Seven main machine learning classifiers, including decision trees, random forest, SBM, and gradient boosting, and found that gradient boosting gave the most promising results. Methodology overview. We built our dataset by combining peptide sequence from 6 well-established public sources, including ACPDL, anti-CP, and cancer PPD. After removing duplicates and filtered sequences to a length of 4 to 50 amino acids, we ended up with 970 unique peptide sequences. Each peptide was labeled as positive if it was experimentally validated as an anti-cancer peptide, or negative if it had no anti-cancer activity. We then encoded these sequences using the Blossom 62 matrix, which translated each amino acid into a 20-dimensional vector based on evolutionary substitution. Next, we padded all sequences to the same length, normalized data, balanced dataset using SMOT, and trained the tested models using 7 different classifiers. Were compelling. Out of all the models, gradient boosting performed the best and achieving an accuracy of 92.09% with strong precision, recall F1 score, and AUC matrices as well. It outperformed even the current state of the art models in the field. And one of the biggest advantages of our approach is interpretability. Unlike deep learning models that are often black boxes, our method relies on biological principles, making it easier for researchers to understand and trust the prediction. Key findings. So, what does Blossom ACPET offer? A biologically meaningful, accurate method for anti-cancer peptide prediction, an approach that scales well even with small to medium datasets, and a system that could be easily extended to other types of bioactive peptides like antimicrobial and antiviral peptides. What's next? Looking ahead, we plan to integrate deep learning for larger datasets, develop hybrid models that combine the strengths of ensemble learning and neural networks, include structural and physicochemical features to further improve prediction accuracy, and release a user-friendly web server for researchers worldwide to access our tool easily. Closing the conclusion, Blossom ACPET accurately predicts ACPs using Blossom 62 features. Gradient boosting achieved the best performance, which is 92.09% accuracy. The model is robust, interpretable, and outperforms existing methods. Thank you all for your time and attention. I hope this will contribute meaningfully to the field of peptide-based cancer therapy and computational biology. I would be happy to take any questions.
Sir, any questions for ma'am?
Yes, I have a few doubts in my mind. First of all, the presenter has presented the anti-cancer peptides. Is it a biological method, dear author?
Sir, I would love to invite my co-author Mugdho. He will be answering all the questions.
Yeah,
Okay.
good morning. Good morning, sir.
Good
Yeah,
morning. Is
this
it a
is a
biological method? Yes.
this is a biological method.
Okay. And in one of the slides, the author have presented the whole flow, how we are going to proceed into the method, where the first
Mhm.
block is regarding the collection of the data set. So
Correct.
from where actually you have collected the data set? Do you have any
Contact.
collaboration with
Yeah,
any of
yeah,
the
yeah, yeah.
hospital or?
Yeah, sir. Let me share something. Munta, please go to the benchmark dataset slide.
Yeah.
Okay,
We have used the benchmark dataset actually. Yes, sir. Here you can see. So the source of the dataset is ACPDL, ACPPP, and ACPFL and TCP. Those are all the benchmark dataset we have used, and along with them, we are creating the dataset from here, and then we can divide it into two classes, which is positive and negative.
correct.
So that is why we are creating our dataset mainly.
Okay, okay. My another point is there any ethical approval is required in your research?
Sir, actually, can you please explain what do you mean by ethical approach?
Ethical approval, I mean to say that at the research level, it is fine that you are collecting the data set and you are
Hmm.
working and analyzing the data set. But once
Right.
your this biological method is proven and it is
Mhm.
applicable to any of the human or any of the animals, I mean
Mhm.
basically for the humans. So at that
Mhm.
time, you need to take a approval from the ethical committee so that you can claim your method, you can justify your method. Have you taken any of the approval, or in future, do you have any plan?
So, yeah, so sir, as my author presenter is already told that in future we have worked with a large data set and using a
Correct.
deep learning model.
Okay.
So in future we have a plan, but for as of now we are using secondary data. So actually for this data, we do not know need any kind of ethical
Correct.
approval
Correct.
is
Correct.
required.
Makes sense. So in future, you have great potential in the because as you are working for the anti-cancer kind of method. So wish you all the best for your future, and you may continue with your research. Thank you very much. I'm
Yeah,
through.
thank
Nimahi,
you,
I'm through.
thank you, thank you so much,
Yes.
sir. It means a lot. Thank you.
Thank you, sir.
Thank you.
Thank you. Now, next, I would like to call Gaur Bhargav Ramesh Chandra. Sir, are
Uh,
you here with us?
yes, ma'am.
Yes, sir. Please present your paper on efficient Gujarati text spotting in natural images using hybrid deep learning.
Yeah. Is my screen visible, ma'am?
Yes, sir.
Okay. So first of all, good morning to all of you. Myself, Gaur Bhargav Ramesh Chandra, and today I'm here to present. Just give me a second. Uh, yes, is my screen visible, ma'am? Hello.
Yes, sir. We can see the title page of your presentation.
Okay. Thank you so much. First of all, good morning to everyone. Myself, Gaur Bhargav Ramesh Chandra, and today I'm here to present my paper, Efficient Gujarati Text Spotting in Natural Images Using Deep Learning. The paper ID is 246. Here is a basic outline of my today's presentation. We'll start with the introduction that what we are trying to achieve in this research. Then we'll move on to the literature study that I've done for this. Then I'll explain you the proposed system, model architecture, and the data set that I've used, and the results that I've got. Once that is done, I'll show a basic comparative analysis of all the other methods with my proposed method. And I'll move on to the conclusion and we'll show you the references. Here, I'll start with the introduction. The field of optical character recognition has witnessed remarkable progress over the years, enabling the text extraction of the textual information from the diverse sources such as scanned documents and natural images. However, recognizing text in natural images, particularly in regional languages like Gujarati, continues to pose significant challenges. Gujarati is one of the official languages of India and is characterized by intricate script and diacritic marks, making it more complex to process compared to simpler scripts like Latin English. Despite the increasing importance of OCR applications and multilingual settings, Gujarati exporting remains an unexplored area, highlighting the need for specialized approach to handle its unique challenges. Our study combines UNet architecture with ResNet 50 and squeeze and excitation blocks to develop a deep learning method for Gujarati text segmentation from the natural images. Here is a basic flow of text spotting where we will provide a input image which is taken from the natural images. Once that is done, we will separate the text from the image, and once that is done, we will detect the text and then we will recognize that what is written in the text. As shown in the figure 1, typical flow diagram of basic steps of any text spotting and recognition system. Gujarati text recognition in natural images faces several hurdles, including the script's inherent complexity, varying font size, overlapping characters, and extensive use of diacritics. Here is a literature study. In my literature study, total 25 paper that I've studied, and I'll give you an overall summary of this. So there are total different methods and why I have included in it. I'll just tell you in short. So the methods like CNN, RNN, SPTS, V2, bilateral segmentation, and curve-based methods, basically they are utilized for image segmentation and feature extractions. Then moving on to the deformable transformation and graph CNN, it is to handle irregular shapes and orientation of the text. Query-based model and multi-granularity helps recognize data in better way. Linguistic prior helps us to predict characters, removing the occlusions. Noise reduction will reduce the noise from the images where the light is low. Here is a basic proposed system that I have been created. First, we will give the images from the data set, that is CBDAR. Once that is done, we will first pre-process it, resizing all the images into 640 by 480 and normalizing it. So we reduce the computational overhead. Once that is done, we'll send it to the encoder, which has total 5 layers made with resonate 50 and squeeze and excitation. Once that is done, then we'll send it to the decoder, which is UNet. Once all of these steps are done, we will have our train model. And once the model is trained, we will put in the test images. After that, what we will do is we will get the all text spotted from the images. To recognize the text, we will utilize PyTesseract. Here is a basic model architecture, including all the layers, starting with input layer, then zero padding 2D layer, then convolutional 2D layer, batch normalization, activation, max pooling 2D, additional layers, dropout layers, global averaging pool, dense layers, reshape layer, multiply layer, and upsampling 2D layers. Here are the dataset details. The dataset used for the study is the CBDR dataset, which is specifically curated for the text spotting and recognition task in the Gujarati script. The dataset contains a diverse collection of natural scene images featuring Gujarati text. It includes variety of challenges such as complex background, varying light conditions, font style, text sizes to emulate real-world scenarios. The dataset is annotated with the ground truth information, including bounding box, coordinates, text regions, and their corresponding Gujarati text labels. This annotation ensures accurate training and evaluation of the proposed model. The images are pre-processed to a fixed resolution of 640 to 480, which I mentioned already earlier, to maintain uniformity and reduce computational overhead during the model training. Additionally, normalizing techniques are applied to enhance the quality of input data by mitigating variations caused by illumination or contrast difference. The inclusion of this database enables the model to focus specifically on the Gujarati script, which is distinct due to its unique characters, curves, or diacritics. By using CBDR Gujarati dataset, the proposed framework effectively captures the nuances of the Gujarati scripts, making it highly suitable for real-world text spotting and recognition tasks in natural images. Here is basic fine-tuning parameters that I've utilized. The input shape, as I've told you, it's 480 by 640. The encoder that I've used is resonate 50. The optimizer is Adam. Learning it is 0.0001. Loss function is utilized by binary cross entropy. The metrics used or is in focus is accuracy. The epochs are 30. Batch size, as per training step, we can vary it, but currently with my implementation, that is 4. The number of layers are approximately 150, which varies from layer to layer. The dropout rate is 0.5 and squeeze excitation block ratio, that is 16, which is default. Here is an example of the dataset sample where you can see the image or the text that is written in the image. It is pretty dark. So you can see the contrast difference is there, and we were easily be able to detect the text from it or separate it from the image. Here is a basic graph of the train and validation plots. Here are a few other examples of the text spotting and recognition. Here is a comparative study. So the first method is text spotter. Second is mobile net V2 and UNet. Third is text block. Fourth is transform. And the last one is our proposed model, where we have given the three basic parameters considering the GPU accuracy and training times. So in text spotter, you can see the GPU is required. The accuracy is approx 74% and training time is 24 to 28 minutes. In the second mobile net V2, GPU is always required. The accuracy is pretty good at 88.20% and the training time is 22 to 26 minutes. The text block, GPU is not required, but as you can see, the accuracy lowers at 79.30% and the training time is 28 to 32 minutes. Moving on to the Z transform, GPU is again not required. Accuracy falls down to 65.12%. Again, the training time is roughly same at 28 to 32 minutes. And our proposed model, in this, the GPU is required, but the accuracy reaches to 91.80% and training time is less to 12 to 18 minutes. Here is the conclusion. The overall things that I've told you in the comparative study, the same has been written in the conclusion. In the future, the model will be capable of performing segmentation and real-time application by binding a new model using the YOLO and MobileNet V2 architectures. Here are the total 25 references that I've utilized. Thank you.
So, any questions for him?
Yes. The presenter has presented actually a framework which is regarding the Gujarati text spotting. From the image, they are extracting the Gujarati text. So I want to ask to the author that are they require the kind of quality of the image so that the Gujarati text could be spotted, or any of the rough image your model, your framework could work?
Sir, currently I'm focusing on the natural images where the lighting condition and all the different scenarios are there. So regardless of the complexity of the image, my model can extract the image, extract the text from the image.
Okay. And one more thing, that yes, your model is absolutely fine, because as in the comparative study, you have shown that your the framework accuracy is 91.80%, which is excellent. Also, the
Yes, sir.
training time is 12 to 18 minutes, which is also
Yes, sir.
appreciated. Only the
Yes,
thing
sir.
is, actually, which are the application where exactly your research is applicable?
Sir, currently mainly is for the text detection, that if we have various images like currently. So as of now, I'm developing this method for the better text extraction of the local languages, that India have many local languages. So first, if we can easily extract
Correct.
or very efficiently extract the text from that, then we can move it to the live application, which can be utilized for easy translations or real-time
Okay.
examples
Okay.
where you
So,
can direct. Yes, sir.
correct, correct. So in future, do you have any plan to go for the same kind of framework for the other languages as well?
Yes, sir. We can do that.
Okay, okay, okay. So thank you very much, and you have presented a nice lecture. Thank you.
Thank you so much, sir.
Thank you, sir.
Thank you.
Okay, we'll move to the next one. Samruddhi Samir Patil. Samruddhi, ma'am?
Hello, hi.
Yes, ma'am. Please present your paper on intelligent plastic waste segregation system.
Yes. Good morning, everyone. I would firstly like to thank the conference organizers for giving us the opportunity to present here. I'm Samriddhi Patil, and I'm here on behalf of all the authors to present the paper titled Intelligent Plastic Waste Segregation System. So, these are the this is the basic outline of the presentation that I'll be following. I'll first walk you through the background of our research, which is mainly based on the enormous amount of waste that is generated annually in India. Around 9.3 million tons of waste is annually generated, which the major inefficiency in the system is that we cannot uniformly segregate it in different types and recycle it. So what our proposed solution is, the solution consists of a robotic precision and advanced algorithms to classify and segregate major 4 categories of waste. Now, these categories of waste we have selected based on the literature review that we have done, and on basis of the overall consistency of waste that is generated. And we have found out that HDPE, which is high density polyethylene, low density polyethylene, and polypropylene, along with PET plastics, are the major contributors in the waste. So we have taken those four plastic grades and are uh, and have made a robotic solution to segregate it. So this is the implementation block diagram of our system, which consists of a conveyor belt. So the plastic uh, first falls on the conveyor belt from the feeder mechanism. Once the conveyor then aligns it and places it under the camera, which uses vision and AI models to identify the plastic waste, and a robotic gripper then grips that particular waste and segregates into the four-mentioned categories. For this, the controllers that we are using are Arduino and a CNC shield, along with stepper motors for the robotic application. So as I mentioned about the hardware design, the XYZ Cartesian bot, also known as a planar robot, is made up, we constructed it out of an aluminum extrusion frame, and we used a timing belt pulley system, and the gripper was 3D printed, and we specifically used soft body gripper such that the orientation of the waste wouldn't matter a lot. As you can see in the following slides, this is the implementation of the entire system. The brown block in the beginning is the feeder mechanism, which is directly connected to the conveyor, which then the implementation process flow is then created. This is the CAD model of the soft body gripper. The gripper is made up of PLA and TPU. TPU is a flexible plastic material which can be 3D printed. Now talking about the software architecture, the YOLO V8N model was specifically chosen for its speed and accuracy and was trained over 100 epochs on a custom dataset which we created based on the wastes and the general category of waste that we had initially defined. The dataset consisted of 483 images, with 71% was allocated for training and 15% was dedicated for validation and 14 for testing. Each image contained an average of 2.7 annotation, the boundary boxes that we created for each waste, to ensure that the model learned to recognize different plastics under varied lighting conditions, orientations, and partial occlusion. The implementation pipeline integrates RoboFlow for data management, TensorFlow and OpenCV for image processing, and custom Python scripts for real-time object detection and robot control coordinate. This is the flowchart of the model. And now this is the flowchart of the model implementation. First, first we have loaded the YOLO model and the web camera. The YOLO V8 can be used to detect objects in real time on video incoming from the camera source. It executes the OpenCV resolution at 640 to 480. It begins by analyzing each frame, detecting things enclosed by boundary, score, and confidence. The system integration. The complete system execution flow involves synchronized conveyor operation, object detection, coordinate transformation, path planning, precise robotic arm manipulation, and accurate waste placement into designated bins. A reference point system was established to convert camera coordinate space to robot coordinate space, allowing the XYZ Cartesian bot to precisely target detected objects with minimal positioning error. The soft body gripper's servo-controlled actuation was calibrated to apply optimal gripping pressure based on detected plastic types, ensuring secure handling without crushing or dropping the items intermediately. This was the hardware that we made, and these are the different views of the entire system. Now, talking about the results, the YOLO V8 model achieved the exceptional performance with confidence scores consistently ranging from 0.9 to 1% for most prediction, demonstrating a robust object recognition capabilities. The precision confidence analysis showed HDPE and PET bottles maintained high precision of 90.95 plus even at low confidence thresholds, while PP plastic achieved 0.8 to 0.9 precision at higher threshold. The difference in this is mainly because of the light reflection capabilities of PP plastic, and this was one of the problems, and hence we integrated a inbuilt lighting solution to overcome that issue. The kernel density estimation curve for the confidence scores peaked at 0.95, indicating strong statistical reliability of the object detection system across multiple plastic types and environmental conditions. This is the real-time detection and path planning. So a reference point is previously defined in the YOLO V8 system. And according to that, the XY coordinates of the objects are then taken in, and then this signal is then processed to the motors via the CNC shield, and the robot moves the gripper to that particular location, and then the Z axis actuation takes place. For this, what the major hindrance for us was that the accuracy detection of the centroids of each object and the gripper and the accuracy of the gripper to reach there. The graphs on the right are the confidence score distribution curve, the precision curve, the precision confidence curve, and the precision recall curve, as I've mentioned the results in the above system. So the detailed precision recall analysis confirmed outstanding model performance, which HDPE achieving 0.995 precision, PET reaching 0.944, and PP attaining 0.757, contributing to an overall system mean average precision MAP of 0.899. The comprehensive time analysis revealed a 30-second cycle time per object with 4.2 seconds for visual processing and decision making. The remaining time dedicated to the precision mechanical movement and object placement. The system demonstrates consistent performance over extended operations periods with minimal drift in accuracy or positioning. The practical performance, now talking about the practical performance, system successfully demonstrated complete end-to-end plastic waste segregation from detecting to sorting the waste physically. The real-world testing confirmed the system's ability to process multiple plastic types simultaneously, correctly identifying and segregating items.
Excuse me, ma'am. I'm sorry for
Yes.
interrupting, but this is a reminder that you've crossed your 9-minute mark, and I would request you to end your presentation within the next minute.
Yes, I'll just go over the future scope. So the current cycle time is of 30 seconds, and it could be optimized through a parallel processing technique and hardware acceleration. So currently we had to create the model which was fairly small on a smaller scale. So in the large scale industry scale application, we can ideally reduce this processing time by 40 to 50%. And integration of collaborative robots, like multiple robots and AI-enforced feedback mechanisms, could scale the system to comprehensive waste management. Yes. So these are the references that we followed. Thank you so much. I'm now open to take any questions.
Sir, any questions for ma'am?
Yes, I have one question to the presenter. I think
Yes, sir.
the research is related with the waste management, the segregation of the waste, and then for the disposal. So
Yes, sir.
the thing is, you have very good precision in HDP like 0.995, in PET is it 0.944, or for PP it is 0.757.
Yes, sir.
Have you think about the approximate cost of your project?
Sir, the current cost of creating just the prototype or the proof of concept model was somewhere around 25 to 30,000. Just talking about the from the material perspective. This is not
Correct.
including all the
Correct.
manufacturing costs. So that is our current
Okay.
expense.
My one suggestion to you is
Yes,
your
sir.
of course the research and whatever the procedure you followed for the segregation, it is absolutely fine. But I think this would be more applicable to the rural areas. So try to develop your your research and try to apply your research to the rural area where such kind of waste management systems are not up to the mark. You know, because
Yes, sir.
sometimes they gather the waste at the end of the village or between the two villages in near any of the farm, so it could be harmful to the human beings. So my own model
Right.
would be more or less applicable to rural areas more than the city areas, because in city areas such kind of methods and the procedures are there. So rather than that, you focus to the rural areas. That is what my suggestion is. Thank you very much.
Thank you for your suggestion, but sir, we'll definitely consider it. Thank you so much.
Sure.
Thank you so much, ma'am.
Thank you.
Now, next, I would like to call Sai Siddharth Gimedi. Sai, sir.
Am I audible?
Yes, sir. Please present your research on multimodal generative AI for plant disease detection.
Sure. Just give me a minute. Is my screen visible to you all?
Yes, sir.
Okay. Thank you. So, good morning, everyone. I am Saisita Jemedi, and I am excited to present our work on developing a multimodal AI framework for robust plant disease detection using CLIP and CNN. Okay. So, coming towards the introduction, Uh, plant diseases are one of the major challenges in agriculture today. They lead to reduced crop yield and threaten food security on a global scale. Traditionally, disease detection is done manually, which is time consuming and labor intensive and often inaccurate. Okay, so here's where like challenges occur in this field. So like we have manual inspection that is very inconsistent, and traditional methods rely on manual visualization inspection of plants, which can not be so much accurate. So there is a need of technology to come into the picture and take an action. And other thing is like time consumption. It is very slow process as it's a manual inspection, and so much of labor will be required for the work. Okay. Next, in advancement learning plant decision. Now we have introduced CNNs in our work that has revolutionized the field of image analysis. Okay, they enable automated detection of plant disease by learning from large data set of images, and the image-based detection that CNN analyze the visual features in images to classify plant disease accurately. This approach significantly reduces the time and labor involved in all manual inspections. So during these things, we encounter some challenges despite their effectiveness, CNNs face challenges such as sensitivity to the environmental changes and overfitting to the commonly known diseases. These limitations can hinder the performance in real-world agricultural settings. Now, the multimodal integration leverages edge over the traditional methods. This multimodal approaches improves the accuracy and interpretability in diagnosing plant diseases. So coming to our dataset, we have a dataset, the plant doc and the new plant disease dataset consisting of images of healthy and diseased crop leaves categorized into 38 classes. It contains around 87,000 RGB images, offering an comprehensive representation of these images are required pre-processing for the model by ensuring uniform data distribution, and data preparation is essential for improving the quality well-structured data, which leads to a better one visual data. Models like SVM, KNN, and even CNN perform well in closed environment but fail to generalize. In contrast, multimodals can learn from multiple sources, images, text, environmental data, and more robust. Our approach aims to align visual symptoms like yellow spots with textual cues, making the diagnosis more grounded and interpretable. Okay, so I will just brief a model architecture. Okay, so we propose the integration of CLIP with a CNN-based model to leverage both architectures. The CNN is good at extracting fine-grained visuals features such as color changes and spots, which are very important for plant disease detection, while CLIP provides multimodal reasoning by aligning image features with textual descriptions. This synergy enables valid predictions of CNN against disease-specific descriptions for a better accuracy, robustness, and interpretability. For instance, assuming the CNN predicts apple rust leaf, CLIP ensures the correct text alignment in response to symptoms such as textural yellow-orange spots or early fall of leaves. In the combined approach with the added confidence in diagnosis and provides an effective solution for precision agriculture and automatic monitoring of plant health. So this is how our CNN model and the CLIP integration works for the enhanced detection of plant diseases. So the plant dog dataset is organized and the images are pre-processed, and then a pre-trained ResNet 50 model is utilized for extracting visual features from the images. The model is fine-tuned on the dataset to enhance its classification capabilities. Next comes vision language alignment. Creates semantic embeddings by matching image features with textual descriptions. This alignment ensures that the visual features correspond accurately to the disease symptoms described. Then the integration mechanism. The CNN predicts the disease categories based on visual features and extracted from the images. Clip validates these predictions by calculating the similarity scores between images and the text embeddings. Then comes the diagnosis. The combined approach provides semantically verified diagnosis of plant diseases. This integration enhances the overall accuracy and interpretability of the detection system. So, coming to the results, we have achieved an 87% accuracy in detecting plant diseases using our model, and this model outperforms traditional methods in agricultural disease detection. So coming to output, this is our output what we have got for the given input plant diseases. So since the model relies on pre-trained feature embeddings from ResNet 50 and CLIPS transformer, it classifies its classification is restricted to the disease and plant types. A leaf that belongs to a plant species absent a labeled disease class instead of mapping it to an unknown category. In this case of unseen diseases, the model predicts the similarity, leading to the potential misclassification. Moreover, the present implementation of zero-shot learning can only rely on some level of semantic alignment between known and unknown cases. The model may also be prone to overfitting to frequent diseases, which reduces its ability to generalize outside the dataset. And I would like to conclude this by saying that uh, a multimodal plant disease detection system that merges CNN's visual strength with CLIP's language understanding, and the approach not only improved the classification accuracy but also made the model explainable, user intuitive, and
Is my voice audible to all?
Yes, it is audible.
I think the presenter had some technical glitch.
Correct. So, Dimay, we can skip the question answer session for that particular presenter, and you may invite
All
the
right.
next one. Okay. Thank
All
you.
right, sir. Zornitsa Yordanova. Zornitsa ma'am, are you present in the session? I'll move to the next one. Jnaneshwar Natha Vabhal. Jnaneshwar sir.
Hello, ma'am. Am I audible?
Yes, sir. Please present your paper on optimizing liver transplantation outcomes, an advanced machine learning approach for donor matching and survival prediction.
Yes, sure. Thank you, ma'am. Able to see my screen, ma'am? Hello.
Not yet, sir. Yes, sir. We can see your screen now.
Oh, okay, ma'am. Thank you. Thank you very much, ma'am. Yeah, good morning, all of you. Myself, Naneshwarnath Hawawal, and today I am going to present my research paper on topic optimizing liver transplantation outcomes. It is an advanced machine learning approach for donor matching and survival prediction. So these are all author, my guides, Dr. Pankaj Agarkar sir, Sachin Sakre sir, Parikshit Mahalle sir, Yashwant Dongre, and Nitin Thorve. So next one, these are the my outlines that I am going to cover in this presentation: problem statement, introduction, motivation, and all. Okay, so this is my problem statement. I am going to develop a framework for recommendation of best match donor before liver transplantation for the patient who is undergoing for the liver transplantation. So this is the introduction. Actually, liver transplantation is a critical procedure for patient with end stage liver disease. Actually, what happened in liver transplantation is nothing but the replacement of non-functioning liver, that is you can say that failure liver or disease liver with the healthy liver from another person. So liver transplantation is the treatment that option is given for the end stage liver disease and acute liver failure. Although it is totally depends on the availability of donor organ, is a major challenges, or you can say that it is a limitations. So most common techniques in nowadays also, that is nothing but the orthotopic transplantation, in which the native liver, it can be removed from the donor body and replaced by the donor organ in the same anatomic positions as in the original liver. So there will be the surgical procedure, it is get carried out, and it is very complex, as it requires very careful harvest of the donor organ, and the duration of that particular surgery is near about 6 to 18 hours. It is depending upon the outcomes. So there are various kind of risk while doing this liver transplantation. Very first one, it is liver rejections after transplantation, and another one, it is in order to avoid such that such kind of rejections, I am going to develop this new framework for the liver transplantation. So and next one, it is very helpful for all means suffering patient. It can save lives, but it success heavily depends upon the compatibility between donor and recipient. So existing model for matching donors and recipient often lack have the predictability rate. So data used in this current model can be easily distorted and leading to the suboptimal matches and outcomes. Enhance predictive accuracy using advanced machine learning techniques. So these are my motivations. Due to this, I am eager to develop such kind of framework. Very first is enhance patient outcomes. So over there, by using that, one, we can do that improve survival rates and reduce the complications that comes in liver transplantation for the transplant patient. Second one, it is we can address organ shortage, so optimize donor organs use to reduce wait time and leverage technology. Over here we are going to apply artificial intelligence and machine learning to improve the donor recipient matching, and finally ensure the ethical standards, so promote fairness in organ allocation and protect the patient data privacy. So my aim is to this research is to develop a robust recommendation framework for identifying the best match donor before liver transplantation for the patient that is suffering from the end-stage liver disease. So by leveraging these advanced machine learning techniques, particularly I am focusing on multi-layer perceptrons model. The framework aims to accurately predict donor recipient compatibility. This will be enhance patient survival rate and outcomes, so streamline the donor matching process and the ultimately improve the efficiency and effectiveness of the liver transplantation procedure. So these are my main objectives that I am going to carry it over here in my research. Very first is to review and analyze the literature of existing model thoroughly. Second one, it is to collect the data from different sources, implement attribute selection techniques for pre-processing, to design and apply an advanced machine learning multi-layer perceptron approach for achieving accurate and effective prediction survival before liver transplantation, to implement the proposed system to predict survival before liver transplantation in the time among live and dead is estimated based on the poor as well as best rate survival. And last one is it is to validate the result of the framework for the best match donor before liver transplantation for the patient who will undergo the liver transplantation. So these are many more papers I have used for literature survey. So over there I can understand that none of them that they are going to use different kind of algorithms. So over here I am going to use multiple algorithms to achieve the success. Very first I am going to use going to implement cloud based hybrid model with neural network, that is NNN, for the prediction of long term survival, okay, for the liver transplantation. Second, I am going to use PC algorithm, that is principal component analysis. It is get used for the ranking attributes. Third one, it is to implement the attribute selection techniques with data pre-processing. Then to upload the predicted data on cloud. For that purpose I am going to use cloud. Over there, next one algorithm I am going to use tenfold cross validation algorithm, that is used to apply on the medical input data sets available from UNOS database. There are various kind of database data sets we are going to use in order to achieve the success rate. So over there, one of the data set, it is UNOS one. Actually, so for these data sets, we are going to they have the near about 1,06,000 patient records, and they are dealing with 389 attributes from 1st October 1987 to till date. So from these 389 attributes, they have taken 259 attributes to achieve the liver transplantation success rate. Over than last 10 last uh, last 2 decades, they are using 70 attributes that is get used for the donor attributes. Out of these 70 attributes, some are the donor attributes, some are the recipient attributes, and some of the matching attributes. So over here I am going to reduce those 70 attributes up to the 28 attributes. So this is the recap of our previous work. So this is my proposed architecture. So the very first, the person who is undergoing to go for the liver transplantation, he needs to register himself for that particular hospital. Okay, so in India, you know that they need then we need to be registered for the concerned hospitals through online registration form that is available on URL like noto.gov.in, that is National Organ and Tissue Transplantation Organizations. Okay, the and so first we need to talk with our doctor about liver transplant. Then we need to visit that particular transplant center, then get evaluated from expert, means whatever doctors are there. Then after get approval for the liver transplantation, and then only it is get placed on the national waiting list. Okay, those who want to undergo for any kind of organ transplantation, they need to go register themselves national waiting list, and after that confirmation receives from live donor match if they choose particular transplantation liver type. okay, then only that person undergo for the liver transplantation. So this is the hospital through who we are going to do our registration. Then data collection layer. So over here, see donor data, age, sex, HLA, cross match, recipient. These are the attributes we are going to match, and some external data blood test. So all these it will be go for our pre-processing the data. So over there we are going to use dimensionality reductions with principal component analysis and standardization of data. Then whatever features are get extracted over there, then we are passing to the multi-layer perceptrons. And over here there is a trend MLP that is help to reduce the features. And over here it undergoes to the prediction of donor recipient match compatibility. And over here these are the some evaluation parameter. On the basis of that we are going to predict the survival rate of that particular patient, and that is
Excuse me,
accuracy,
sir.
precision. Yeah, ma'am.
I'm sorry
Yeah,
for interruption, but you
yes.
have crossed your 9-minute mark. Please conclude your presentation in the next minute.
Yes. So these are the methodologies: data collection, data pre-processing. We are going to use these are the methods: subtract mean data from, calculate convergence. All these algorithms I am going to use over here, and the basis of this model of end-stage liver disease. So MELD score. On the basis of that, we are going to achieve the best survival rate. If MLD score is less than greater than 50, then it is the best survival rate, and if it is greater than the 50, then there will be the poor survival rate. So these are the basic steps that is involved for the liver transplantation from both the perspective receiver as well as donor. So these are the data sets I am going to use. UNO's liver transplantation datasets available on Kaggle. Then Optim datasets and liver transplantation in serious data sets. So these are the future selections that I am going to use. I am working on these 28 attributes. So uh, over here this is the proposed algorithm, and finally I am going to conclude that this research work, it is concentrate on the developing excellent prediction techniques for the liver transplantation. There are these framework I am going to involve comparison with several conventional approaches like KNN, SVM. Okay, and finally this advanced multi-layer perceptron approach is more successful than other existing linear models, and predicted survival is more effective to take decisions easily for the physician as well as patient. So this proposed system is to predict the best outcomes of the patient after the liver transplantation. These are the some experts. I am going to take guidance from them, Dr. Bipin Vibhute and Dr. Manoj Dongre. So these are the various references I have used for my research. Thank you. If any questions, please ask.
Sir, any
Yes.
questions for him?
Yes. Here, sir, I have a question that you develop a framework that is for the liver transplantation. Do you need to take any ethical approval for this kind of research in future?
Yeah. Actually, first upon, I am going to use one case study. So these experts, they have given some actually they have the some their research they have done for particular patient. They have given their own data right now. So I am working on that, and that is one the ethically proven data they have given. Dr. Bipin Vibhute and Manoj Dongre, they are helping me on that one. Okay, once that model it is get fulfilled and it pass all the phases of that, then next onwards there won't be any kind of ethical considerations we are not going to take.
Okay. So my best wishes to you, and I hope your research would be applicable to the society, and the society get benefited. Thank
Yes,
you.
sure, sir. Sure. Thank you very much, sir. Thank ma'am.
Thank you, sir.
Yeah, thank you, ma'am. Thank you very much. Thanks, all of you.
Sir, please stop your screen share. Yes,
Yes,
thank you.
ma'am. Thank you very much.
Next, I would like to call Shripad Venkata Pradnyuman.
Hello,
Sir,
am I
are you
audible?
present? Yes, sir. Please present your study on quantum computing comparing standard algorithm performance, its applications, and relevance of quantum digital twins in healthcare.
All right. Good morning, everyone. It is my honor to be here at ICTIS Thailand to present our work titled Quantum Computing, Comparing Standard Algorithm Performance, Application and Relevance of Quantum Digital Twins in Healthcare from our research team at Amrita today. So let me walk you through our exploration of how quantum computing, an emerging computational paradigm, can revolutionize key applications in healthcare through theoretical foundations, some benchmarks that we've made, and an empirical comparison with classical methods. So, what is quantum computing? To give you a background, quantum computing relies on qubits instead of classical computing that rely on bits. So, in qubits, a state can be 0 or 1 or both simultaneously in a probability distribution. This gives rise to several atomic phenomena like superposition and entanglement. In superposition, a qubit can represent 0 and 1 simultaneously. This allows for massive parallel computation. And in entanglement, the qubits are correlated, which means the state of one qubit instantaneously influences the other, regardless of distance. What this means is that we don't have to wait for the signal to propagate in the minute distance between the transistors. For example, in the current transistor scenario, and a chip architecture may boast of 3 nanometer, 2 nanometer. Light still takes time to travel between that. The electrons themselves still take time to travel between that distance. Quantum mechanics theoretically promises instantaneous influence. So these efficiency gains are in factorization, optimization, number theory, machine learning, and several other fields. So quantum computing's utility is not hypothetical. In drug discovery, the accelerated protein ligand interaction simulation can accelerate drug discovery. In cryptography, the potential to break the RSA algorithm using Shor's algorithm. In finance, we can improve risk analysis and portfolio optimization. And in machine learning pipelines, at every stage of the pipeline, there is a speed up that can use quantum computing. For example, these are some of the papers where quantum computing has been used to enhance scalability, security, or speed, and otherwise improve the accuracy as such. So our work here shows that a quantum support vector machine achieves comparable performance to a classical support vector machine, even with the significantly reduced features that our current hardware, which is very compromised with regards to quantum computing, we're able to achieve comparable performance even with that constraint. So our study follows a systematic literature review. We covered around 2,700 papers across the three major databases, IEEE, Explore, Science Direct, and ACM. And after rigorous filtering based on the inclusion criteria, we have around 536 papers that were retained. The inclusion criteria was tool discussion and domain relevance, which we kept to be healthcare, and the tools that we are going to show you later. So in benchmarking the quantum simulators, we benchmark them using Shor's algorithm. Shor's algorithm is a quantum order finding algorithm that basically finds prime numbers that can be used to break the RSA cryptography algorithm. We've also, for the machine learning evaluation, in the classification task, we have used a support vector machine using the tool QuizKit by IBM versus a classical support vector machine on the UCI breast cancer Wisconsin dataset, and compared them as follows. So for the Shor's algorithm benchmark, we have compared them using gate count, execution time, error rate, and qubit count. So gate count actually represents the number of quantum operations. The lower they are, the less noise prone it is. Execution time refers to the wall clock time for simulation, and error rate is the frequency of incorrect factorization result. For the classification task, we have used metrics like accuracy, precision, recall, F1 score, and AU-ROC, which is area under the ROC curve. So this is the current trend of the tools in the various databases. We can see that there's an exponential increase around 2019, which is where noisy intermediate scale quantum hardware by Google and Microsoft got popularized. This is where IBM's AER background was created and made open source. So this represents a more number filled metric of the same thing. So we see that QuizKit is well represented across all datasets. TensorFlow Quantum is unfortunately depreciated now. So, and Circ also is a growing presence with Percival and BlueCat, two open source options. They are not extremely present in these databases. So upon comparing them, we see that BlueCat has the highest gate count and error rate. Circ has the lowest error rate and execution time. Percival has the lowest gate count, which makes it very efficient for photonic circuits, and that is the purpose that it has been developed for. Qiskit has moderate performance all around, and the reason we see its execution time being higher here is because of potential simulator overhead due to the fact that the IBM quantum hardware backend was unavailable and we had to use the Python simulator. So these are the metrics that we got for the classical classifier, the classical support vector machine, on various fractions of the data set and on the full data set as well. We see that it reaches very high accuracy, around 98%. The surprising part here is that we see similar performance in the quantum support vector machine, even though we use PCA for it, reducing 30 features into 4 components. So so this is the ROC curve comparison, and we attribute this difference in ROC due to the quantum support vector machine's PCA limitation. So what we see here is that quantum theory's advantage in high-dimensional Hilbert spaces, where qubits enable richer feature representations, allows for better encoding of complex data structures, as well as speed up in resolving higher data manifolds. So, discussing the future of quantum technology, as mentioned in terms of research, quantum research has had a significant rise in publications post-2019. Right now, Qiskit remains the most supported, and previously it was TensorFlow Quantum, and it has since been deprecated. So right now, in hardware constrained solutions, there is still potential for quantum support vector machines to resolve high dimensional data, but hardware improvements are crucial. We see right now, this year, in fact, the Majorana 1 chip by Microsoft and the Willow chip by Google, they have promised scaling of error correction along with qubits. So this set of algorithms promises great benefits for the future of quantum computing. And we see that it's mainly applied in healthcare applications such as drug discovery, genomics, and imaging. So coming to one of the future directions that we want to focus on, the digital twin. So the digital twin is a virtual representation of a physical entity that updates with real-time data. So for example, we can simulate a patient's response to a treatment or a disease, personalize health plans accordingly. So its applications are not only in healthcare, but also supply chain logistics and manufacturing as well. So how quantum digital twins work here is that it's a hybrid architecture that allows the simulation of intractable biological and molecular systems. So a biological or molecular system is a highly complex, highly feature heavy data set where a classical machine learning model would not be able to keep up with that scale. The reason we use classical machine learning models for biological processes is that it offers explainability. Even though neural networks and deep learning approaches have shown significantly better outcomes, we need to trust that what we are doing in terms of a person or a biological process is rooted in statistical truth. So there needs to be that ground reality. So in such a case, using quantum digital twins enhances the accuracy and efficiency of complex simulations in machine learning. For example, Bosch is currently simulating protein molecule behavior for drug discovery. So yeah, quantum digital twins has shown that it leads to better research and development, greater operational efficiency, and improved product end-of-life management by IBM. This is with regards to their supply chain management and logistics. So
Excuse me, sir.
yes, sorry.
Please end your presentation in the next minute. Yes.
Yes, sure. To conclude, quantum computing holds a lot of transformative potential in healthcare, from diagnostics to personalized treatment design. And while current hardware poses some constraints, there are advancements in quantum simulators and even hybrid models which are paving the way for real world impact. Our study shows that a quantum support vector machine offers competitive results under these hardware constraints, and its power will only grow as the quantum stack matures. Thank you. Thank you so much. That's my presentation.
Sir, any questions for him?
Yes, I have one question. First of all, it is always feel nice that today's technology like AI or machine learning or all these kind of tools are utilizing for the healthcare applications. And the authors have done a very good comparative study, and they have presented the quantum digital, quantum tool for the short algorithm. So, my question to the author is, do they have any kind of collaboration with the hospitals? How they have collected the data sets for the analysis?
Yes, sir. So this data set was collected from Wisconsin Hospital in collaboration with the University of California, Irvine. So this data set is about breast cancer. So based on certain biological features, 30 biological features, it predicts rather it is a labeled data set of based on these biological features, whether the person has breast cancer or not.
Okay, so I think you should carry on this particular research as this is you can say that the fight against the breast cancer. So wish you all the best for the future, and you may continue this collaborative work. Thank you. Best wishes from my side. Thank you.
Thank you so much, sir. Thank you.
Thank you, sir. Now, next, I would like to call Gokul Siddharth S. Gokul, sir.
Yes, ma'am.
Yes, sir. Please present your paper on sustainable coconut byproduct management using machine learning.
Is my screen visible?
Yes, sir. Your screen is visible.
Okay. So good afternoon to one and all present here. Myself Gokul Siddha, here to present our work on sustainable coconut byproduct management using machine learning. And my co-authors are Harisudha Kuresan, Aishwarya Sham, Kabilan, and Prithviraj Rajlingam. So this will be today's agenda for the presentation. Introduction to coconut byproducts, challenges in coconut industries, proposed machine learning solution, methodology and results, and future work. Coconut byproducts such as oil, copra, coir, and activated carbons play a vital role in industries like food and cosmetics, where they are in high demand. However, their production faces significant challenges as the market volatility often impacts farmers' profits. While the high processing cost makes sustainability difficult, additionally, resource waste such as discarded husks harms the environment. The coconut industry faces several critical issues: fluctuating market prices, creating uncertainty for farmers, and making it hard for planned productions. And the high labor and varying processing costs for each byproducts makes it more harder for small-scale farmers to gain a profit out of these byproducts. So even the small-scale farmers have very less access to real-time market data, which leads to inefficient production decisions and financial losses. To address these issues, we propose a machine learning based solution. Our approach uses an ensemble machine learning models to predict the prices of each coconut byproducts accurately. We use models like XGBoost, CatBoost, and Random Forest to ensure robust predictions. And the goal is to optimize production for maximum profit while reducing the waste through sustainable practices. Our methodology begins with a comprehensive data set of 440,000 records spanning from the years 2002 to 2024, all sourced from the Tamil Nadu Agricultural Portal. We have processed the data by cleaning, normalizing, and performing feature engineering to extract meaningful patterns from the data set. Key features include seasonality, processing cost, and market trends, which influence the byproduct prices. We then develop an ensemble model to enhance the prediction and accuracy. The performance metrics used for these models are MAE and R-square score. So this is a visual representation of our ensemble model, where the XGBoost, CATBoost, Gradient Boost, and Random Forest are our 4 base models. Those predictions from our 4 base models are then fed into the meta model, that is our linear regression, for more better accurate predictions. So this is the model performance of each individual models and the ensemble model. Here we can see that the ensemble model has a significantly better MAE scores comparing the individual models. So our results demonstrate that the ensemble model outperforms each and every individual models, achieving the lowest MAE for all byproducts. Additionally, the model consistently achieves a high R-squared score, indicating it's a good fit for market dynamics. These reliable predictions enable farmers to make informed market decisions and have a better profit. So in conclusion, our ensemble model ensures accurate predictions for the byproduct prices and also supporting sustainable practices. It empowers farmers with actionable insights to optimize production and reduce waste. And as for the future works, we can add an anomaly detection feature and also the weather data, so that the predictions can be much accurate. And also we can explore reinforcement learning for adaptability and also to expand the data set to other states. So any questions?
Sir, any questions for him?
Yes, the authors have presented a ML model, to predict the price at the coconut byproducts. So,
Yes.
in future, do you have any plan to go for the other products as well once you succeed for the coconut products?
Yes, actually, there are lots of other byproducts for coconut as well. Due to the data constraints, I have stick to these 4 byproducts. I plan
Correct.
to expand using other byproducts as well for coconut, as well as other commodities, sir.
Okay, okay. And do you have any, for this particular thing, you need to work in a team. So right now, are you doing research alone or do you have other team as well?
No, sir. We have we are a group of 3 and we share our work, sir.
Okay, okay. So I think you need to, you need to add some more members in your team once you expand your this particular work. And
Yes, sir.
are you targeting to any of the group of the people, or it is for the generalized for the society?
So this is for the farmers with the benefits. So
Correct,
I plan
correct,
to deploy a model where they can just enter their production for the month, and it will give you a detailed processing cost and number of days for each byproducts, so that they can make better decisions. Like instead of just giving out the raw coconut, they can just make better decisions
correct.
and add value to the product and gain profits also. And we can also reduce the waste, sir.
Yes, correct. So I think you have presented a nice research. Only one suggestion is there from my side. Is
Yes.
apart from research, it is also very important to aware the farmers regarding your research.
Yes, sir.
So my suggestion is you plan a training kind of thing, or you can have the explanatory videos or some kind of things by which the farmers could get what you have done for them, and then they may start getting benefit from that. Okay.
Yeah, sure, sir.
So my
Thank you for
best,
the insight, sir.
okay. So my best wishes to you. Thank you. I'm
Thank you so
through.
much, sir.
Thank you, sir.
Thank you. Thank you, everyone.
Now, next, I would like to call Ishan Bhattacharjee to present his study on zero short and few short named entity recognition in biomedical domain.
Hi, am I audible?
Yes, sir.
Okay, I'll just share my screen. Okay. Is my screen visible?
Yes, sir, we can see your screen.
Just start the presentation view. Okay. Oh, it's still visible, right?
But we can also see the pop-up notice.
Oh, okay. Right. Now?
Yes, sir.
Okay. Okay, so I'll start. Good morning, everyone. I'm Ishan Bhattacharjee, and I'll be presenting our research work, Zero Shot and Few Shot Name Identity Recognition, on behalf of my fellow co-authors, HP Pranav, Harish Satish, and our co-authors and project guides, Dr. Preeti P. and Dr. Mamta HR. We are all from the Department of Computer Science and Engineering at PS University, Bangalore, India. This is an overview of how we have structured the slides overall, a general overview. Firstly, to introduce the topic. So, as you will see from the title, it is about name identity recognition. So, name identity recognition is a crucial part of general NLP tasks, any kind of natural processing task, and an essential part of natural language understanding. To understand any kind of given text is important to know what all the named entities are, and as well as to understand so because it makes it much easier overall. So like if you are given a sentence in a general as and a human would also read it, they would know that which all are the named entities in the text and which all are also just general, say, other types of words like pronouns, adjectives, and so on. So a general approach for name recognition has historically been traditional supervised learning approaches, which require vast label data sets, and as a result of which are both costly and time consuming, and even more so in terms of computational complexity and requiring more time for it to be processed. So zero shot and few learning methods are like a sort of solution to this exact problem, which is there that requirement of a vast label data set, and as well as reducing the overall processing time and complexity required to do it. And the idea of the whole zero shot and few shot process is that it should still maintain a comparable performance. So this research investigates the feasibility of these methods for biomedical NER, and for our purpose we use a model transform model known as BioBERT. It's essentially a variant of Google's original BERT, which is fine-tuned on biomedical data. And furthermore, we present an improvement on existing on a base paper which we used in terms of how the exact approach can be done to further reduce the computational complexity. So problem statement. So as I mentioned, traditional NER depends on a huge set of large annotated data sets, which are expensive to obtain and difficult to obtain. And as a result of this huge data set, it also leads to more computational complexity. And there's obviously a shortage of data as always. So there's a need for efficient models which can generalize well with less labeled examples, because will never actually have enough labeled examples. We will always have some deficiency and it's hard to get them. So objective. So our idea was to develop a zero shot and few shot NER model for biomedical domain. And as a result of which we have used a BioBot based model. And the idea of this was to make it as require as this data as possible in order to solve the two issues as earlier, that requiring less data and less computational complexity and less time for like the overall process as well. So, and furthermore, so to evaluate the performance, we have used the F1 score. And F1 score is an important metric for name identity recognition. So hence we have focused on purely that score. And as the main reason why F1 score is important for name identity recognition is that by leveraging and giving importance to both precision and recall, it emphasizes the importance of getting a true positive to make sure that every single true positive is accounted for. And that is because that is a key part of name identity recognition, that everything which is a named entity, which is the correct entity, has to be there. So that's why we use F1 score. Methodology. So firstly, we have used biomedical text data from general open sources which are available on the internet. In some cases, we would have to sign licenses to accordingly use it correctly. And we have processed them to essentially make it into a binary classification tasks, which I'll get into later with the example. So, and from that is where we use a model selection, which is the BioBERT model, and we fine tune it for NER in case of zero shot and few shot learning approaches. As I mentioned earlier, we have used F1 score for evaluation, and the idea of this again was to make sure to give equal importance to precision and recall, and in that way we have emphasized the true positive, and to make sure we all get all the true positives correct. So now to understand one of our approaches, one thing which is really important in our approach we did. So say now this case you have data set 1, data set 2. Now target class we're predicting is disease class. So the disease class is something which is common across these two data sets. But where the difference comes in the data set one, we have a supporting class. Data set two, we have a contrasting class. So supporting class would be say something similar to disease, like say kind of like or like say something like so disease, something similar to disease would be say some kind of sub disease, things like that, right? Or anything like that, which will be kind of supporting classes, and which you have example. I'll give an example of that later on in slides as well. So this is a supporting class, and a contrasting class would be say something that is completely unrelated to disease, say chemical, that is not related to disease in any way. Now, the idea of this process was that with the now, as we merge these two data sets to essentially do the few shot process as well as zero shot process on the model, this better helps the model to understand what disease is. So because it has something which are similar to disease, as well as something which are completely different. So as a result of which, in the few shot and zero shot learning process, and this is where our main novelty comes in, that we can overall by using this property of having both completely different as well as some similar things, we have not only reduced the dataset size from what is required in a base paper, as a result of which also brought down the overall computational time, and we have achieved similar results. As you can see, this is the distribution of our classes. You can see if our target class is disease, chemical is completely contrasted. Now say modifier and specific disease, disease class. So these are things that are slightly similar to disease, but kind of different. But chemical, composite mention, these are completely different from disease. They are no relation at all. And this is how you can see a distribution. It's kind of an similar-ish equal distribution to make sure that the overall model generalizes well and can learn well. This is the key idea which we used here. This is the key novelty which we have to reduce the dataset size, but also keep it in a specific reduction to achieve the good few shot and zero shot performance while reducing the computational time and data required. As you can see, this is the result. So this is the one on the right you see here is the performance of a reference paper, which we use essentially. So then this is the performance of our model. So now you might notice it's slightly lower, but so the reason why it is lower is essentially the fact that despite it being slightly lower, the overall say the reduction of data required from here to here is extremely significant, like beyond 50% reduction in the overall data set required because of the fact that we like the reference paper merely used a generalized data set with multiple different things and got a similar result for this disease class. But we specifically cut it down to a much smaller data set with this very idea that we will use classes which are supporting the target class as well as classes which are completely contrast to the target class to overall get a better idea. So that is how our entire result here. So as you can see, this is a proof that even with significantly reducing the data, we've gotten comparable results. Even with much more limited amount of data, and we have our idea did work. That is the main objective of our research. Now, as an example, so how the whole process worked, I want to just walk through this here. So for zero-shot model, we use it directly with only pre-training. So take the label disease and sentences. So we're just putting this, there's some more pre-processing which sort of goes, which I haven't gone much detail for the purpose of keeping it simple and understandable. Which would this would be like how it is there. Disease is separate, this is a sentence. It's for a pre-trained word. So, and it's priming to look into where all disease is, basically. And then it uses pre-training knowledge to know that Addison's disease is a disease. And these are things which are appear in the context discussing diseases, but cortisone is a drug or treatment and not a disease. And in this way, you can say every word in the sentence is essentially classified, made into a binary classification task for the zero-shot model. And yeah, so as you can see, this is how it looks like the output. So this is how it would kind of marking Addison's and disease as one, right? So this is how you see for every text thing is essentially classifying it as 0 or 1. 0 is not disease, 1 is a disease. And that's how this whole process, that's how we, in our whole methodology, we kind of made it into a binary classification task, which is helping the overall zero shot and the few shot process, and at the same time requires less data overall. And now this is for and now say that's for the our few shot process, which we use 100 examples. So the idea of the whole thing was so for the zero shot process and the like we are obviously more examples of say a target class disease. For 100 shot, we like randomly sample and we like so in the initial step we removed all the disease like the labels which are there. 100 shot we brought back a random set of 100 to overall let the model kind of understand better overall and what is happening. Kind of that's the entire process which we are did here. And that's how, when I say here, we brought 100 examples and all that. And you can see here again, the similar thing which I mentioned that this is a binary classification task. And then this is kind of how it's going overall. And in this, like we kind of fine tune those on those 100 input output pairs which are there. And then this kind of gets it slightly more fine tuned to the data set which is there. And as a result of which it increases the overall performance overall. And in this case, even though the accuracy metric might not be a significant change, but the overall time required, time complexity did reduce compared to the zero shot model. Right. So yeah, and then yeah, as mentioned, kind of same, we do use the pre-training, the zero shot model relied purely on the pre-training of the BioBird model by itself. But this also has 100 disease examples. Now to
Excuse
conclude.
me, sir.
Yes.
Please conclude in the next minute.
Yes. So as you can see, this did we are in our research we did prove that how it is accurate overall. The whole process was high performing and required less data and less time complexity. Now, future work can expand beyond the specific domain which we have taken on biomedical data. And furthermore, there's one issue which I noticed was slight like volatility of the metric, like it was slightly used to go up and down every run. So when with the improvements in transformer models happening daily, this might change further and might become more stable. Furthermore, as and when more transformers can be developed made available for NER tasks, the same approach can be used for other NER tasks as well in other domains as well. And yeah, these are the references which we've used. I thank you all for your time and attention in this presentation.
Yes,
Sir,
I have.
any
Yes. I have one question to the author. The author has nicely presented the zero-shot NER model for the biomedical domain in comparison with the traditional model. Only one thing I have doubt that they have stated that they collect the data from the Google as well. So, is there any authenticity of that data which you have collected from the Google? Because sometimes what happens, the data is not accurate and valid. So, how you are going to validate those data for the analysis?
Okay. So firstly, I would apologize for any miscommunication on my part. Like, I didn't mean I collected from Google, more like public source. So, like in my case, what I would say, I don't think I've written it here anyway, but like the data set. So in our case, we have used two data sets. So one of which is called the NCBI data set, which is like a
Okay,
national collection of like biological information. One more
correct.
CDR, which is chemical disease. So those data sets are are available on the like specific biomedical website. So we've
Okay,
operated under the
okay.
assumption that theirs is correct.
Okay, I got your point. So it is fine. Once you collect the data from the genuine website, that it is absolutely fine. So, again, very nice presentation where the technology would help up to certain extent to the biomedical domain. So, my best wishes to the author and presenters. Thank you.
Yeah. Thank you. Yeah.
thank you so much.
I stop screen sharing.
Yes. Now I would like to ask Zonitsa Yordanova. Zonitsa ma'am, are you here with us?
Yes, hello.
Hello ma'am, please present your paper on open innovation in the era of artificial intelligence.
Thank you very much. I cannot share my screen. Yeah, now it's okay. Thank you. Okay, so can you see my screen?
Yes ma'am.
Perfect. So my paper is about open innovation and this transformational role that open innovation has in the era of artificial intelligence, but it's not only that we are living in another era. All the economic and management concepts are actually not in a danger, but in a transformative years right now. So my paper is about open innovation and how actually all the ideas and collaborations around this theoretical and practical concept has evolved with the advent of AI and exactly the integration of AI, how actually it allows for more efficient data analysis, real-time collaborations across geographically dispersed teams, and the automation of routine tasks that usually are a big burden for open innovation practices. Just as a brief introduction, the open innovation concept is that concept in the management theory that allows us to work on innovative projects openly to the environment and to other teams, companies, and to the ecosystem in general. So AI, from another perspective, is also a tool like this. Being in collaboration and combination, they really experience big changes. So the objectives of the study are exactly to identify key AI technologies that transform the concept and to explore the changes that generally in innovation management models are happening due to the introduction and implementation of AI, and also to examine some challenges and opportunities. For analyzing the ecosystem in general, I invited 5 subject matter experts on the topic, and I'll share with you their insights. We are in the end of the session, so I'm not put any attention of the theoretical foundations, but this is just a slide to orient ourselves and the different aspects that we have when we talk for open innovation and AI in the same time. So these are different models, inbound, outbound, and they are very much related to Industry 4.0 and 5.0 with integration of other technologies like IoT, like automation, robot process automations, big data, and so on. And how actually AI facilitates collaboration in addition. I'll directly go to my findings and to talk about the transformations in innovation management. It's not a surprise that they are in the direction of efficiency, collaboration, and personalized innovation. Which is actually a result of this qualitative approach to summarize and analyze existing literature on AI and open innovation, because this is happening in the last 10 years, but only in the year and so actually it exploded. And the research design actually focuses on identifying exactly these key AI technologies and their application to open innovation. After this thematic analysis, actually, the results of the study are structured around 4 key methodological steps. So first, literature analysis, focus group discussion, integration and synthesis, and clustering into categories. Each step contributes to a comprehensive understanding of how AI is transforming open innovation. The literature review, from one hand, identified several key themes and trends at the intersection of these two concepts, AI and open innovation. AI technologies at the moment are revolutionizing innovation processes with machine learning and data analysis and data analytics as well, enabling vast data processing and insight generation, natural language processing, facilitating structured data analysis and generative AI, augmenting human creativity. AI is also accelerating innovation by automating routine tasks, enhancing collaboration through AI-powered platforms, and providing predictive analytics to forecast market trends and customer preferences is usually things that open innovation spend a lot of money, open innovation models practiced by companies spend a lot of money in the past. So that's why actually such a research is so important in the moment. So the focus group discussions provided practical insights, reinforcing and expanding upon the findings from the literature. And participants emphasized the AI role in enabling seamless collaboration across stakeholders with AI-powered predictive analytics. So at the moment, if I can put it this way, at the moment, in open innovation approach and models, usually all these routine and administrative tasks to schedule and to shadow what is happening in that ecosystem of open innovation actually took a lot of time and money, obviously. So now with this AI approach, basically the usage of open innovation models and making the sense of this concept is much more cheap in general, because these AI models can go and shadow what is happening and even to identify some hidden insights when it comes to creativity, when it comes to insights, market value, and so on. So these are the clusters that came out of the research, and they are in these three main directions, pillars of that impact that AI has on open innovation. And first, we have this enhanced collaboration. Both the literature and the focus group highlighted this role of AI in enabling seamless collaboration, and also all these AI-powered tools, which can really, at the moment, integrate in the rooms, in the halls, in the facilities, and even in the platforms where open innovation happens. When it comes to efficient innovation process, the automation of routine tasks, and we know that this year the highlight of all AI talks is not generative AI anymore, it's more to the agentic AI. So the AI agents are those who are going to really replace that raw profession of open innovation collaborators. And AI-driven decision-making, because this is one of the struggles, the biggest struggles in open innovation, especially when a lot of stakeholders are involved, how really the decision-making process is happening. So the AI-driven platforms and models can enhance this. So this is also one of the directions for future research. And personalized innovations, exactly, namely the ability of AI to analyze and interpret large data sets allows the development of highly personalized products and services. And we as humans are there. Exactly. We've worked a lot in the last hundreds of years, but now with this AI and open innovation, on the other hand, actually we can start really working on personalized innovations and solutions for everyone. Of course, as any new implementation and application, there are a lot of challenges, and in this context, ethical considerations. Of course, data privacy is one of them, and security concerns, integration of complexities, and cost of implementing AI systems. Thanks to the platforms supplied by AI models, it's not that costly anymore. So even end user, or an individual, or a small company, a startup, can actually afford a subscription. And of course, the ethical implications, the bias, the transparency, accountability, and the workforce adaptation. Future trends and opportunities, specifically for big corporations, small businesses, SMEs, and universities, academia, are huge in this field. So hyper-personalization is one of them. I mentioned this on the previous slides. Interdisciplinary research collaborations to enhance real innovation, and also to go to other important for humanity directions like sustainability. And also AI augmented human creativity, one of the most important things and the reasons for still relying on open innovation models. As a summary, I want just to emphasize the main contributions of this article, this paper. They are good directions for further analyzing really the contributions of this cooperation, AI-driven strategic frameworks, efficient innovation management practices, redefining of open innovation concept, the dynamic and interactive innovation models that should be rewritten at this point of the time. And that main advantages that I clustered in this paper: collaboration, efficiency, and personalization. And of course, the main challenges when, of course, we have with the privacy, integration, and ethics. But I think people engaged in open innovation, they're quite experienced in this sense. And they actually do it quite well in the last years of making this happen. And as a final slide, I just want to summarize that I see a big potential for also for theory enhancement when it comes to open innovation and AI. And in some fields and some science fields, open innovation is not that spread. And that's a big call for action for everybody that can start utilizing such models. And of course, there are still that open innovation collaborators, professionals who can make this happen for any team. Thank you very much.
Sir, any questions for ma'am?
Yes, I have one question. The presenter has presented the open innovation concept. It is basically to identify the key AI-based technologies for the certain analysis. So only my suggestion to the presenter is whatever the presentation she has presented is of course very nice. We deal with the analysis. So in the future, they can apply the AI tool or any of the IoT concept to one particular domain, so that the people should get the idea that how exactly AI is going to utilize for the analysis for the certain domain. And once it is there, then you may extend your research for the other domain as well. Otherwise, it was a very nice presentation. Thank you and best wishes to her.
Dr. Pandey, that's a great idea. Actually, I have a lot in mind, and I can also share an invitation to the participants in this section to start trying some open innovation models because I have some AI tools already developed, so we can, in the future try to implement them in the different aspects. I saw wonderful presentations in different fields, so thank you very much for the suggestion, and I'll be happy to collaborate with all of you. Thank you.
Sure. Thank you very much. Thank you.
Thank you, ma'am. Now, I would like to give one last call to Anupama B. Ma'am, if you're present or if any of the co-authors of this paper is present, please let us know. All right, we'll move to the concluding remarks. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the printer and the publication will be live within 6 months. I would request everyone to kindly cooperate with the team of ICTIS 2025. I would also like to thank our session chair, Dr. Kilol Vishnu Prasad Panda, for chairing this session. Thank you, sir, for your presence and sharing a token of appreciation on behalf of ICTIS 2025 and Global Knowledge Research Foundation and partners. I would request you to share any few words you may have for us.
Yes, it was a very nice session, and it was always found pleasure that the researchers have explained and presented their research in the diversified domains like biomedical domain, botanical model domain, and they have utilized how the AI effectively go for the benefit of the society. Also, some of the researchers and presenters have talked about the other IoT model, the deep learning model, machine learning model. So it was a very nice session, and I hope all the presenters would carry their research in the future as well, and they continue with their direction. I also like to thank the team ICTIS for giving me this opportunity, and yes, of course, congratulations, Dimahi, for the nice coordination. Thank you.
Thank you, sir. Thank you, sir. Now, as we end this session, I would kindly request everyone to please turn on their cameras for a quick snapshot of this virtual conference. All right, thank you, everyone. Have a great day ahead. Thank you.